All right, so thank you very much for coming. And this is our second lecture. So as I briefed a little bit before that, I will uh, start recording all the class and make them available for you guys for review or in case you cannot come in person. Okay, so last time actually we already covered the first part and also the first two subsections, including the basic big data concepts and the data models, data concept models, and for the following, I will continue to discuss about the processing, how exactly we process big data, okay? So this slide actually shows that there are totally five steps, because this is a five-step data analytical process, which usually is considered as the most widely used workflow in data projects. Okay, so the first step is acquire. Okay, so this means collecting data from different sources and storing it so that we can retrieve and query it later. Okay, for example, the data may come from different database, logs, sensors. Okay, and also user activities. Okay. And of course, nowadays, the data can be generated by large language models, right? So at this stage, the focus is not analysis yet. So the goal is to make sure that the data is available, accessible, and reliable. So if the data is missing, poorly stored, or hard to query, the later steps will become exceptionally difficult. Okay. And so this is why actually data acquisition is the foundation of the entire data analytics process. Okay, so in most of the companies actually collecting the data and clean and fine tune those data, actually they will cost more than making analysis. Okay. And the second step is to prepare, right? So this is usually referred as what we call the data preparation. Okay, for example, if we are trying to fine-tune a large language model, of course, you need those data and also you need the labels, right? So after acquiring the data, the next step we call to prepare, right? So starting with the data exploration. The first term here is called data exploration. So in this step, actually, we try to understand the data in a more high level. We look at the basic statistics and the simple visualizations, for example, right? Such as the scalar plots and the histograms, right? Like these two examples shown in the slide. So the goal here is to answer the question like, so what does the data look like? Are those obvious patterns? Are there missing values or outliers? So this is to get a very high level understanding about what we are dealing with. Okay, so this is only a very preliminary analysis that we are not building models yet, right? This is have an overview. Okay, this is what we are dealing with. So the good exploration actually help us to spot problem early and get us to, okay, how do we clean the data or to process the data in the next steps? So this is actually quite essential. Excuse me. So quite the essential steps, what we call the exploration. So after exploring the data, the next step in preparing is data processing. Okay, data processing. So data processing focus on making the data usable for analysis and modeling. All right. So this usually includes several tasks, like we listed here. Okay, including the data integration. Okay, which means how do we combine the data from different sources in a single and merge data set, right? And usually the data cleaning removes errors, duplicates, or the missing values, etc. The other one is called the feature extraction, which actually converts the raw data into the meaningful features. Later on, we will also talk about the text mining today, right? Later on, I will discuss, and that also includes a lot of techniques to convert the raw data into meaningful features. Okay. And finally, we also have the feature extraction, right? The feature, sorry, I mean the feature scaling. The feature scaling means actually in many cases the range the feature scale adjust the range of the values so that different features can be compared fairly. Usually, a very typical example would be, for example, we scale the range from 0 to 1. So all the numbers describing the data will be uh, uh, formatted as for example 0.5, 0.6. So we have scaling so that we can do a more fair comparison analysis, etc. So, okay, so the good actually good preprocessing is a very crucial step for the downstreaming applications, right? Because the poor quality input data often leads to poor analysis results. So, yeah. So why the data processing is so important? It's actually because essentially we're gonna build models, right? And the models actually depend heavily on the quality of the input data. So if the data contains errors and noise or missing values, and sometimes even no matter what machine learning models you use, okay, they will always produce poor results, okay, if the data is not clean, right? So this is often summarized, what do we call it, the garbage in, garbage out, right? So I'm not sure if you are familiar with a large language model, right? ChatGPT 1 and 2, remember? So of course, we are all familiar with ChatGPT 3, which is released commercially, right? But if you read their papers when the OpenAI was working on ChatGPT 1 and 2, so they did not have a very intelligent model, essentially because they did not have good data. So what actually significantly boosting their performance is that they hired a manual helper, mostly from the developing countries, I think. So they ask those people to manually determine whether a conversation is good and to ask them to label those conversations. And they use their labels to fine tune and, for example, reinforcement learning that actually significantly improved the performance of ChatGPT, which lead to a usable version. That's then the later stories you guys might have heard, right? So actually the processing here helps remove noise and fix inconsistencies and make the data more meaningful, okay? So it also ensures different features are on a comparable scale, like what we discussed, the scaling, right? So that's actually very important information is not hidden, right? In practice, actually, the data processing often takes more time than model training itself, okay? And this step is actually essential for building reliable and trustworthy data analysis results, and also, of course, machine learning systems. So anyone heard about, so what is the most famous data collecting company? Anyone heard from the US? Because all the large language model companies, right? They OpenAI and Meta, Google, they need the data, right? They need the data, and so of course one way to collect the data is from the internet, but actually most of data is almost used up, right? All the data you can find from the internet is used up, so they need to purchase data from someone, right? So anyone heard about the Scale AI, right? You can Google it. Maybe actually they are selling their main business is to sell those data to large language models. And what's a funny story is that initially it is a very independent company, right? So all the giants like the Meta, Google, they make purchase from them, right? But later on, I think I don't remember. Maybe one of them, I think it's Meta. Meta is trying to acquire the company, so that's actually becoming a disaster for the company itself because it's becoming a increased competition, right? So and the other large language model systems they start to refuse to make a purchase from them because it's from the competition, right? The competitors from the competitors, right? All right, so let's look at a little bit more detail, right? So first one is the data integration. So this is actually a quite important part. In many real-world applications, the data from multiple sources, right? For example, the user information may come from the database, from the logs, from the APIs, right? So data integration combines those different those information from different sources into one single unified view. So that's the objective of data integration. Okay, so this often requires matching, for example, schema matching, right? Aligning the formats and resolving the conflicts between resources, between different data sources. So for example, the same user may appear with different ID, okay, or slightly different names in different systems, especially for example, my name, right? Sometimes my name, I include my alias, right? Jason is not my legal name, right? So I put it in the middle of my legal names because both my alias and my official name are too common, right? Too many people with the same name. Okay. So without proper data integration, analysis results can be incomplete or inconsistent sometimes, even if each data source is correct on its own. So that's the problem, right? Data cleaning, okay, another key step is data cleaning. So in real world data sets, this problem actually quite severe, right? And we often see missing values, duplicate records, outliers, okay, so that do not look reasonable, right? So data cleaning actually is the process to check those issues and decide how do we handle them, okay? So for example, we may remove the duplicate entities. If you see in the data set, we have two things identifying the same object, then we remove the duplicates, okay? We also need to check whether the data labels are correct and whether the values follow the valid formats, for example, right? Data cleaning improves the data quality and helps ensure that the later analysis and the models are based on reliable and consistent data, not the accidental errors. So that's quite essential part. Okay. Unfortunately, it sounds you may when I ask people to do data cleaning for our projects, usually they do not like it. They sounds like labor work, right? But they are quite essential. So if you look at this picture, illustrates several examples. The table shows common data quality problems are often fixed during the data cleaning, right? We may see the missing values, there are fields are empty, okay, and invalid values. So such as the impossible ages, right, and incorrect categories here, right? So there can also be duplicate records, which well as the uniqueness of constraints, right? Another issue is the format inconsistency. Okay, for example, the dates. For example, the dates here, right? There are many different ways from Europe, American, right? The different format of the dates. We also need to check the attribute dependencies, right? Such as whether a city matches its country and fix misspelling, for example, to prevent the correct matching, right? So also we need to identify and correct those issues actually to identify and correct those issues is an essential step to ensure that the data is accurate and consistent before we can perform any modeling and analysis, right? Another important step is the data processing. In the data processing is the feature extraction. Okay, feature extraction means transforming the raw data into usually numerical features that models can process. Okay, while keeping the important information from the original data, right? Later on, we will introduce in textual data, like our English, right? Documents. How do we deal with it? How do we do feature extraction, right? So if you read any paper, usually the feature extraction is the most technical part, right? of the usually research projects. For example, text can be converted into numbers using the word counts and embeddings, right? And the images can be represented by, for example, pixel values or high-level features. Okay, so the goal here is not to keep all the raw data details, but to keep the most useful information for analysis or prediction. Right. And good feature extraction often has a huge impact on modeling performance. Okay, for sometimes even more than the choice of the learning algorithm itself. How do we extract features? Right? And the last part is the data processing of data processing is the feature scaling. Right? So usually this is very straightforward, right? Because the feature scaling adjusts the range of feature values so that different features are on a similar scale, right? A very common method is normalization, right? So where the values are rescaled into a fixed range, for example, from 0 to 1. Right? So this step actually is quite important because many algorithms are quite sensitive to the scale of data. If one feature has very large scale, right, very large values, while the others has small values, right, then the large one may dominate the model, right? So this a typical example is that when we talk about for society, right, for people, when we talk about the average income, right? So sometimes when we talk about the average income, it's not a very good reflection about how the society is going, right? Because a few of the people, they have a huge amount of income, right? So that will make the average income quite high, but still there's the Gini index could be high. That means it's few of people get a super high income, while the others has little, right? So this is not a good reflection. So what we what, when we're trying to understand the income of a population, for example, so usually we also think about the median, right? The if we rank all the income in the society and we take the one in the middle, right? Taking one in the middle. So that is a better reflection about how people get income in a society, right? So that's a typical example. So usually the feature scaling actually helps really a lot for the models to learn more what we call the fairly, right, and efficiently from those features. Right? Uh, okay, one common technique in scaling is to find a range. This is actually this is slide demonstrate an example here, right? So here you can see that we rescale the values so that they fall between a minimal and a maximal, often between 0 to 1, right? So this makes the value easier to make comparisons. Okay. Um, so the chipping set minimal and the maximal limits to reduce the impact of extreme outliers, actually. Um, uh, and sometimes they also take the log. Right? The log scaling is useful when the data spans a very wide range, such as the income or population, right? So actually the example here shows how salary are converted into a scaled value, giving a clear representation of each value's relative position within the range, right? So uh, a very interesting example, if you think about all the class, right? All of us, we are regular people, right? Sitting in the class. So think about if Elon Musk come in, right, or Jack Ma come in, then that one person will significantly improve our average income, right? But of course, so that people, those people will be considered as outliers and should be not considered when in part of our analysis. Okay. Another common feature scaling method is, I think we also discussed a little, right, about the log scaling. Log scaling applies the logarithm, right, log, okay, to the original value. Now, this is especially useful when the data spans a wide range of and grows exponentially. Some of the data they will grow exponentially, such as for example, the population of people, or the transaction, right? So if you look at those numbers, then they grow exponentially, and usually we take the log to make the analysis make more sense, right? Or reasonable, right? So by taking the logarithm, right, the large values are usually comprised, and the small value become more distinguishable, distinguishable for the small values. So this often makes patterns easier to see, and of course, the models may be easier to train if we do this. So this is actually a very common practice um, for data preparation, right, for machine learning. Like for in example here, the salaries are transformed using the log function. Okay, and that in that way, we reduce the gap between the small and the large salaries, right? And log scaling provides a more meaningful and stable representation overall, right? When we work with data that varies over several orders of magnitudes, right? All right. Another way is about is what we call another method is called the z-score normalization. Okay, the z-score normalization transforms a value by subtracting the mean and dividing by the standard deviation. Okay, so this tells us how far a value is from the average measured in a standard deviation. So actually, for most of the data we collected from the real world, if you do not how the data is distributed, then we assume it follows a normal distribution. Okay, so after the transformation, the data is centered around zero, and most value fall within a small range. Okay. So this is especially helpful when we want to compare features from different data sets or detect outliers, since unusually large or small zero scores stand out clearly, so we can understand who are the outliers. A zero score normalization provides a very standardized way to represent data and is commonly used in statistical analysis and machine learning. Um, I'm not sure how you in your other uh, courses or in your undergrad study. I'm not sure how you get the grade. In some of the universities, they do it that way. When you have a score, right? You have a final score for the course, for example, and then the lecturer will take the mean, right? So think about you all have grades, right? You have your marks, for example, some 80, some 40, right? You take the mean. And then the mean means you get a B, right? You get a B. And if you have one standard deviation, then you got a B plus. Then another standard deviation, you get a A minus. Then another standard deviation, you got a B plus, A plus. And the backwards the same. If you are one standard deviation lower than the mean, you got a B minus, etc. Right? So this is in many universities they use this. So that's in such a method that avoids that when sometimes the final examination can be super difficult. So actually everyone get a low score, right? So in this way, that also compares how people perform academically, right? So actually, this in our example here, after applying the transformation, so each value tells us how far it is from the average, and the negative value, right? Negative value means you're lower than the average, right? So so that means you're below the mean, right? And a positive value means it's above the mean. Okay. So in the table, you can see that the employees with the highest salary has a positive z-score, of course, right? Well, the lower salaries have negative z-scores. So this magnitude shows how unusual the value is. Okay. So this makes it easier to compare values across different features and to identify potential outliers. Well, this score normalization is especially useful when the features allow a roughly normal distribution, of course, right? And the relative difference matter more than the absolute values. Okay, so this is a very standardized and widely used way, the Z-score, right? Okay, so after the data is prepared, we can move on the analysis step. So in this stage, we build models and choose appropriate analytical techniques based on the problem we want to resolve, right? For example, the clustering is here are some widely used methods like right. So the clustering is usually used to discover groups in data without labels, right? And classification usually predicts a category, such as the spam or not spam emails, right? We receive a lot of emails, so we can determine which are the spam, right? Also, regression usually is used for predicting a numerical value, like the stock price or the demand of a product, for example. Another famous, widely used method, the technique is the association. Right? So the association analysis looks for relations between items, such as the products that are often brought together. Right? I'm not sure if you heard there's a very famous example in data mining called the beer and the diver, right? The beer and the diver. So when people analyze the data for the purchase of their customers from a supermarket, they realize that, well, people usually make purchase of beer and diver together on one bill. Although it looks like super counterintuitive, right? It's strange. It's very different from our intuition. Why is that? Right? But that's what's happening. Right? So the key goal here is to train the clean and well-prepared data into patterns, predictions, or insights to answer the real-world questions. For example, when we know that, well, although we do not understand the diaper and the beer are always sold together, so what we should do about it? We put them together, right? We put them together on the supermarket. So or on online shop, when we see someone make purchase of the diaper, they will also recommend the beer. Right? So that's something we can do about it. Right? So after analysis, the next step is the report. Right? It's the report. The reporting means we're presenting the data and the results in a way that people can easily understand. Okay. So this is usually done through visualization, such as the charts, the graphs, or the dashboards, right? Actually, the visualization helps to reveal the trends and the patterns and also make comparisons when they are hard to see from the raw numbers, right? So it also allows others to quickly grasp the main findings, right? So from this one, of course, you can see that these two data are highly correlated. So common tools for this step include, for example, you can use Python. Later on, we will our TA will also do a tutorial to use Python, right? Also R and the D3 and the visualization platform like the Tubular, right? There are a lot of them to demonstrate the data. So a good report does not only show the result, but it clearly communicates insights and supports decision making. So actually, we do a little bit of research about data reporting, and there are interesting findings. Like so, if your visualization are well presented, if you hire someone with art backgrounds to make the table look nice, right? Then that will make your report much more convincing. People are very subjective, although they do not realize of that. So if you have a nice way to present the data, then people are more likely to be convinced, right? So That's very interesting, something interesting. So the final step is, of course, to act, right? To act. So now we got the reports, we are gonna do something about it, right? So the acting means we use the analysis result to make decisions or take actions. So this could include, for example, business actions. For governments, they make policies, or sometimes we make system updates based on the insights and or we discovered from the data, right? An important point here is that the process is iterative. It's iterative, so it's like a loop. So after taking actions, we will generate new data, and those data will be feedback into the whole round of analysis and lead to new results. Then we use the new results to take other actions. So it's a iterative, recursive process. Okay? For example, after changing a recommendation strategy from, for example, the Taobao, right? We collect new the user behavior data and analyze it again to see if there's change should be happening, right? Then we make some multi-updates on the apps, okay? And then we'll have new data based on your updates. So big data analytics is therefore not a one-time task, okay? But it is a continuous cycle of data analysis and actions, okay? That's basically about it. I'm not sure if you have any working experience in the internet companies working with any particular products. You know, for most of the products, when the first they nowadays follows a quick release principle. Right? So if we have an idea, we make an app or product online and make it public, right? So then we invite people to participate using our apps or products, and then we collect the data, and then we use those data to fine-tune or to improve our product. So in the old-fashioned way in the software engineering, usually we need to think about everything, right? So we need to think through the entire product, what it looks like, and then we design them, and then we release the software, right? But nowadays, it's not the case. Everything is data-driven. We will have a minimal usable version. Think about maybe 10 or 15 years before the first version of WeChat, right? The first version of WeChat was super easy, super simple app with minimal functions, right? It's to chat to friend, that's it. And then we use those data we make analysis to improve new functions and right. So to new features, right? That's actually data. Nowadays all the software engineering is becoming data driven. Okay. So this slide actually shows that a big data-driven approach from a technical perspective. The process, here, it starts with raw data, which can be structured, semi-structured, or unstructured, such as the database, text, image, right? Then the data goes through the data preprocessing, including the noise, the cleaning, the transformation, feature selection, and we make them suitable for the later analysis. Then we introduce the domain models. We encode the domain knowledge and to help decide what the information is useful for building the models. So on the top of that, actually data analytics is applied. Okay, so this includes, for example, statistical learning, machine learning, some usually with optimizations and data mining techniques such as, for example, later on we'll also discuss the classification, regression, clustering, associations. Okay. So finally, we got the results are interpreted to produce predictions, for example, right? And also the real value. So all those supported with the big data techniques like, of course, from system level, we usually use the Hadoop distributed database, right? So that's a very high level technical perspective of them. So this figure illustrates a typical database, big data analytic pipeline. This is a pipeline showing how data flows from a system from from end to end, right? So from start to the end. So the pipeline usually begins with the data structuring, right? So the data capturing. So how do we get data first? Where the data is ingested from usually multiple sources, such as the application, sensors, logs. Okay. Next is the processing, which includes streaming and the batch processing to clean, transform, and prepare the data as it arrives. Okay. Then the processed data is then stored in the data lakes. Now, data lakes is becoming a popular term nowadays. If you go to, for example, Alibaba, right, they also talk about data lakes and also data warehousing, where it can be managed efficiently and accessed by different users and systems. So after that, we analyze the data using the query engines, right? And also the analytical tools to extract some insights. Essentially, we want to have some insight. We want to know something from the data that others do not, right? Of course, in most of the cases, the data will tell us something that fulfill our expectation or our instinction. But those are not the most used. They are usually those kind of information. Sometimes it's not so that valuable, right? Because we know that already. But the most valuable information are those counterintuitive. There are some information that are quite different from what we think that is supposed to be. So if you go to the finance firm, right, they're always looking for counterintuitive insights, right? So if you have an insight that's quite different from the markets, that gives you a good opportunity to make money, right? Because you know something that is different from the market, right? So after that, we analyze the data using query engines and analytics tools to extract the insights, and finally the results are usually used for advanced analytics, such as machine learning, dashboards, decision making, etc. So the key idea is that a scalable pipeline separates those stages. Okay, so each part can grow and evolve independently. So each step in the pipeline can be considered as an independent part, and people doing research, right? For every single of them. Okay. So yeah, the last one topic is about data analytics, right? So there are basically two types of analytical results, right? It could be either descriptive or predictive, right? So either we are trying to understand something from the data, or we try to predict something, right? The descriptive analytics usually focus on understanding the past. Right? So it uses, for example, data integration, summaries, and data mining to answer questions like, okay, what happened, right? For example, the monthly sales reports, the website traffic dashboards are descriptive. Okay, we want to understand how much sales we made in the past month, so how we are going, right? So the predictive analytics, which is usually we consider more valuable from a business perspective, is that we try to look forward in the future. I want to know what will happen now in the future. So it uses statistical models and forecasting techniques to answer a question like what could happen in the future. For instance, we're predicting the next month's sales and estimating the risk of customer churn are predictive tasks. Right? We want to predictions. And of course, sometimes we try to understand how the stock market is going, right? That's also predictive. Right? So in practice, descriptive analytics are often come first because we want to understand what happened in the past, and we want to understand the nature, the intrinsic nature about your application or your business, and the predictive analysis builds on top of it, right? Okay. In machine learning, usually we differentiate in two parts, in two ways for the analysis. Okay, a very simple characterization is to consider them as supervised and unsupervised learning. Supervised learning, I believe you must heard about this before. Right? Supervised learning use labeled data. So we got the data and the labels, right? So where the correct output is known, right? So we know exactly, for example, what object is included in a picture, for example. So the goal here is to learn a mapping from the input to output. Right? Common tasks include, for example, classification, such as the spam detecting, and regression, such as the price prediction, right? Okay, I'm not sure how many emails you receive. I receive hundreds of emails every day from my university account. So sometimes I also receive quite a large amount of spamming emails. Okay. And another category is what we call the unsupervised learning, which works with unlabeled data, right? Here is no predefined output for those kind of data, and the goal is to discover structure or to understand the nature of those kind of data. So the typical task includes the clustering, okay, clustering, which like the groups of similar data points, and also the association analysis, which finds the relations among different items, right? In short, the supervised learning basically predicts unknown targets, while the supervised learning predicts known targets, and unsupervised learning explores the patterns that are not explicitly labeled. Okay. So actually, these slides give an intuitive comparison between, between the supervised and unsupervised learning. So on the left, you can see the supervised. This is on the left is the supervised learning. So the model is trained using labeled data, meaning we already know the correct answers. So during the training, already the model retrieves directly feedback and learns from the predicted the output. Okay, such as classifying the colors of the predicting the values, for example. Right? So on the right, actually, is the unsupervised learning. The data has no labels at all, so uh, the model does not actually receive a direct feedback. Instead, it tries to discover patterns or structure by itself, right? For example, the association rule, right? Like the Deborah and the beer thing, right? So such kind of grouping similar data points together. Basically, all this unsupervised learning is about make a similar things together, right? We cut the clustering association is true. It's somehow like how do we discover those items that the inherent patterns among the data. So supervised learning learns from examples with answers, while unsupervised learning finds the structures without being told what they are looking for. Okay, but that's about it. So this is actually a very high level, is very high level workflow of supervised learning. Okay. So we start with a data set and we split in two parts. One is training and the other is testing data set. So the training set is used to learn the model, to train the model, while the test set is kept separate for evaluation, right? I believe if you took a data mining course, you might heard about tenfold. The tenfold usually we split the data into 10 parts. We use 9 of them for training and the rest one for testing, right? So an algorithm applied to the training data is built on a model, right? During the training, usually the algorithm optimizes the model parameters to reduce the prediction errors, right? So you need to have optimization functions or objective functions. So after training, we evaluate the model and the test data set to see how it works, how it generalized to the new unseen data. Of course, a very direct, obvious question is why not we use all the data for the training, right? But that will lead to what? Overfitting, right? Overfitting because the data sees all the data already, and that will perfectly learn everything about the data set rather than what it represents, which is actually a more general scenario, the essential features, right? So this separation between the tech training and testing is quite important to avoid overfitting and to obtain a fair estimate of the model performance. Okay. In supervised learning, we can see here is this is what we call the regression. Right? The regression is a very common task in supervised learning. Basically, the purpose is to predict a continuous value like the stock price, okay, such as the housing price, the gold price, right? A simple example is linear regression, right? Maybe the easiest one is linear regression. The idea is to feed a line, basically to feed a line. We can find a line that going through the data points and the best capture the relations between the input and output. Okay, so in the figure here, you can see that the input is house size measured in square feet, okay? And the output is the price. So basically, the model learns a line that summarizes how price changes as the size increases. So this is very obvious. Of course, that the larger size is more expensive, right? Okay. Yeah, once the model is trained, we can predict the price of a new house based on this its size, right? So, right? And this slide actually introduced classification. It's another key task in supervised learning. So classification is used when the goal is to predict a discrete label, right, from a fixed set of categories. In other words, the output here is a class, right, not a number, right, class. So common example like we already described it before, the spamming emails detection, like the product categorization, weather prediction, object detection, etc. Right? So the figure shows a multi-class classification setting here, right? Where the data points belong to different groups and the model learns the decision boundaries that separates them. So essentially we are trying to understand what are the boundary among different classes. So there are many algorithms for classification, such like the k-nearest neighbors, decision tree, naive Bayes, random forest, neural networks, etc. So there are so many of them that we will cover a few in the rest of this semester, I think. And yeah, that's the basically about the supervised learning. And for unsupervised learning, this is basically about clustering. So what is clustering is to find similar points together, right? That's the very simple understanding about it. So in clustering, all the data has no labels, okay? And the goal is to discover natural grouping based on similarities. Okay, so this algorithm decides, which data point belong together, right? Which data points they should group together, right? In our case, they are reflected with the colors, right? So clustering is widely used in practice, for example, in the network analysis or the image clustering or the customer segmentation, right? The key idea is that clustering helps us to understand the structure of data where no prior labels, we have no any labels are available, so we can clustering. Okay. So that's all about the very high level introduction about big data computing and analysis. So any questions from for now? Okay. Um, if no, maybe we take a 10 minutes break. Okay. And or 10 minutes. Yeah, the timing is perfect. So we take a 10 minutes break, then we move on the second part about the analyticals. Okay, analyticals. And of course, you are all welcome to take some chocolates during the break, right? All right, so if you guys are ready for the second part of the class, we may get started. Okay. Um, okay. So actually, what we discussed before is a very high-level introduction about okay, what is going on and the industrial and the real-world applications and the principles, the pipelines about big data analytics. So this is a very general information for you, right? But from now on, it will be a little bit technical, okay? Yeah, but of course we were trying to be slow. I understand some of you guys are not from computing backgrounds, right? So we will be I try to be explicit, okay, and to be including most of the details, right? Um, so so from now on we will be discussing different methods, classical methods for data analytics, okay? So we will study different methods and techniques to analyze and understanding large data sets. And they are considered as the classic approaches. So what are the non-classic approaches? Usually when we talk about new and trendy and non-classic methods is about large language models, okay? But here we actually introduce the foundations, right, or the classic methods about data science and AI. Okay. So we will introduce the key concepts and the tools and the practice that are commonly used in the industrial applications. Okay. And hopefully this will build up some real world problem solving skills. Okay. Before we go into the details, like we may make some announcements. The first one, because many students asked me about the final exam, right? So basically, we're gonna have an open book exam. So everyone is allowed to bring one piece of A4 size paper to exam the venues to the exam venues. Okay, and you may also bring a standard calculator, okay, without AI. Okay. There, because I saw some the calculator they have superpowers, right? So there is a agent embedded in the it's like there's a doughball inside the calculator. Please, that's not fair, right? So regular calculator is fine, okay? And also we're gonna do a group presentation later on. We will try to create a forum in the Blackboard. So you can make connections with each other, but eventually it's your own decision to make to form the groups. Okay. And so here is what we are going to proceed. Okay. So you guys make your own group first, but if there are someone left without groups, I will assign them randomly. But of course, you can make friends in the group, form your groups by yourself. Is that okay? So later on, we'll also try to create a Excel, and you may nominate your team members by yourself. Okay. Um, so if anyone, I will assign randomly for the rest of the people who do not find a group yourself. All right. But that's the plan. Okay. And of course, all the learning materials like class slides, the reading list, and also the video recordings will be available on the Blackboard. So you may check from time to time. Okay. Okay, any questions regarding to those issues? If no, let's continue. So actually, we begin with a little bit recap, right, about what we discussed last week. Okay, so actually, here are some characteristics about data. We talked about big data applications and big data characteristics. We got 4 V's, right? So years later when you go interview and maybe people ask, okay, what you learned from big data? Of course, you may mention about algorithm technically, right? But from the conceptual level, you need to remember the four V's, which are actually the most conceptual information you should take away from the class. Okay. So the what are the four V's? So remember the volume, the velocity, the variety, and the veracity. Okay. Veracity. Okay. Okay. And also, here is the overflow about the big data computing and big data analytics. So firstly, we got the data, right? Then we build up with the computational infrastructure. Then we perform the data analytics. And lastly, we go to the applications. Okay, so this is all very high level recapped about this. And also about the data models, let's quickly recap about the data models, which actually describe how data is organized and represented. So firstly, on the left, we can see there's a table, right? Which is the most common and the data model. So each row is called a tuple, right? It's called a tuple, and each column is attribute. Remember those terms, right? They are also used if you took any courses from a database system. If you took data from undergrads, then you must be familiar with those terms. And we got each row is called a tuple. Each column is an attribute such as name, age, salary, right? This is typical structured data in relational database. Then we also have a textual data. The text data like the sentence or documents, like in our case, the John likes to watch movies, right? Those are unstructured data, meaning we do not have a fixed table format for its natural language, right? And on the right, we also see a graph data model, right? Here, the data is represented as nodes and the connections, node and edges. If you took a course like the graph theory, right? The graph theory. So, by mathematically, each graph is denoted with the nodes and the edges, usually represented the V and the vectors, right? And also the edges, E, right? Such as the people and their relations, right? So this is actually useful for usually, for example, the social networks and recommendation systems. Right? So at the bottom, we also see some image data where the data is stored as pixel values, okay? And also the audio data, which is represented as signal over time, time series. And finally, we also have trajectory and location data, which records the movement paths, right? Such as the GPS trees from tourists and the local users, for example, right? Trajectories, right? Also, like we just discussed about the different process, right? From the data integration, the data processing side by side, right? About the data integration, cleaning, extraction, and scaling. And then we got the supervised and unsupervised learning, right? And also we need to report the data with some sort of visualization. And with the reports, we'll get some insights or useful information that we can make an act. We can act on something, for example, make new policies, update your apps, change your strategies of sales, for example, right? And then of course, after the X, everything will be changed, right? So then you can go through recursively, right? So for the whole process. So essentially, the big data process is by default iterative process. Okay, and also we got different the infrastructure like the Hadoop, MapReduce, etc. Right? And just like we discussed before, some of them are some important parts includes the feature extraction, right? Those are most technical and important parts. So feature extraction is about how do we make raw data meaningful with a minimal amount of information while representing the inherent feature about it, right? And unsupervised clustering means we try to find the inherent patterns, right? For example, if I ask you guys to form groups, right? That is naturally clustering. You will cluster with each other and make group for the presentation for our group project, right? So actually, there's no pre-label or predefined labels or facts about the data, and we find the information inherited from the patterns. Okay. So among all the data processing steps, actually the feature extraction is our main focus today. Later on, I will also talk about how do we make extracting key feature from textual data, right? Textual data like natural language or documents. Okay, so for the rest of today's class, we will focus on how to extract the features on text tags. Once we have good features, then we can apply method like, for example, the similarity search or the clustering. Okay, so everything we study next is about the feature extraction and how it supports data analytics. So let's now move to the next part. Okay. Okay, so here is basically the outline about what we are going to discuss for today and maybe the next week as well, right? So in this slide, we begin with the text analytics, right? So text analytics involve analyzing and deriving insight from text, right? So this fills various applications like the feature extraction and the similarity search, right? So if you Google something or you Baidu something, that's by naturally is a text mining, right? By default. Okay. So feature extraction is the process of transforming the text data about the text data into a format that we can easily analyzed by computers, by software models. Okay, so this typically involve identifying important words, of course, right, and also phrases. Okay, and also quantifying them, quantifying. But this step is quite crucial in most of the applications as it allows us to better understand the underlying structure of the text, okay? All right? Or the human language. So, okay. So next we will have similarity search and as a very important part of the technical perspective, the techniques, okay, which will allow us to find and compare texts based on their content. It can be used in many applications like the document retrieval, recommendation systems, and also search engines, example, etc. Right? And also we will also explore the unsupervised learnings, unsupervised algorithms, right? Especially focus on the clustering algorithms, right? They are actually clustering is a very important technique used to group similar items together, right, without prior labels. So two important ones are under this category are the k-means and the dbScan, right? The k-means and the dbScan, those are the terms, and those algorithms are somehow should be your please install those knowledge into your system. Okay, those are, if you go to an interview, that's a must know, right? If you do not fully understand about k-means, you may look like an amateur, right? So those are the terms and the algorithm you must understand if you go to interview anything about the algorithm or data mining, data analysts, those kind of positions, all right? So finally, we'll also discuss a little bit about hierarchical clustering, which actually that is to build a hierarchy, like a hierarchy, of clusters. And this is particularly useful when the relations among the data points are important to analyze. There's a natural hierarchical structure in the data, so that's also quite widely used. But the k-means and is the most famous one, actually, right? All right. So to begin with, all right, we first examine the term of when you do text mining, okay, or NLP, right? Neural language processing. The first terminology you should understand is the document. So what is a document? So basically, a document is a very broad term in our daily life in English, right? Regular, but in text mining, the document can be referred to any written text. So basically, if you have a written text that we can regard it as a document, right? So this includes the text message, blog posts, reviews, right? Hotel reviews, for example. So each of those forms serve to communicate the information or opinions. So everything, basically, everything is a document. Okay. For example here, right, we have example here, right? We have example of a document presented as a hotel reviews, right? So this review states, okay, it is a hotel, quiet hotel, cheap hotel, right? So it's $200, right? At hotel, it's a nice hotel. So basically, those are comments for the hotel, right? So this example actually conveys key information about the hotel and the cost, the general, quality of the staying, for example. So by analyzing those documents, we can easily understand. We can easily understand how people express their thoughts because we speak the language, right? But this understanding is crucial for a lot of fields, including the communication, marketing, social science, etc. Right? So the simplicity of language in our example illustrates how effective communication can be achieved through straightforward descriptions. So actually, human language is a very powerful representation of information, actually, right? So then we, of course, after with this information, we may discuss the documents should be considered both from the forms and its functions in the conveying messages, right? So this is actually a tag, what we call a document, okay? So here are quite a lot of examples of textual data, right? Text data. Here are so many examples you can see from the slide. Okay, a common source is reviews. We see a lot of reviews, right? Like the platform, like TripAdvisor, OpenRice contains a large number of reviews. Okay, and the other important category is the blogs and the macroblog, like Twitter. Now it's called the X, right? So, um, such as the posts on the Weibo, right? Right. So these texts are usually short, informal, and posted in real time, right? Which makes them quite useful for trend analysis and public opinion monitoring. So actually, in Western countries, there are many research groups they trying to actually they serve for the political purpose, right? So they analyze how people feel about different parties when how people will vote eventually, right? So, and there are also a lot of companies they try to use those data to manipulate the voting. So, if you Google it, you can find a lot of such kind of examples. And another interesting direction is in the finance. Many if you go to the finance firms, the hedge funds, you'll see they always have some system to monitor the tweets from Donald Trump, right? So whenever Donald Trump they make a tweet, right, then they usually lead to or going up or down about the stock market, the crypto markets, right? So those are becoming more important indicators than what people believe, because the decision makers, their opinion actually are much more influential, and those information will be reflected in the finance market right away, right? Um, so finally, we also got the instance messaging, right? We use WeChat in Hong Kong. People also use WhatsApp, right? So those generate massive of conversational text every day, right? So although those texts come from different platforms, from data analytics perspective, we often treat them as a document. Everything is a document, can be analyzed with similar techniques. Okay, so textual data is everywhere, right? The reviews, social media, forum messages. Okay. So now let's talk about text analytics, right? We know everything is a document. So what is text analytics? So text analytics means extracting useful information from the text data. So what we can learn from those texts, right? So one simple intuitive technique is called the word cloud. I bet you see it somewhere, right? So people collect some opinions, some data from the crowd, and a word cloud visualize those keywords based on how often they appear in a collection of documents, right? So the word appear more frequent are shown in larger fonts. So for example, the data is the large one, right? So that means in the document it appears frequently, okay? And so this gives us a very quick overview about the main topics of the text, right? Although it does not capture the meaning of the content. So this is a very straightforward, simple way to do this, text analytics, right? But it's too simple, right? Okay. Another very important way is another important task is searching. Searching, for example, we Google something when we're trying to find something, we Google it, we Baidu, right? So here the goal is to find documents that are most relevant or most similar to a given query or document, right? We try to find something with those keywords, your input, right? So search engines like Google and Baidu are classic examples for those kind of large-scale text analytic systems built on this idea. In the old time, when we try to find something, we Google it, right? Or we Baidu with the keywords. And nowadays, what do you do? What do you do when you try to find something? You still Google? Yeah, for me nowadays I use ChatGPT, right? We ask Doubao, okay, can you tell me something? Right? So see the technology is actually driving us and change our behaviors rapidly, right? So yeah, that's what's happening. Okay, so okay. So for text analytics, the first task is about the clustering, right? So the clustering basically groups documents based on hidden topics, right? When we think about when we have a huge amount of web pages, right, or the books, right? So how do we organize those information? We do clustering, right? And clustering groups documents based on the hidden documents without using any labels. Of course, that's because we do not have any labels. For example, the new articles and the sports that can, if you find some articles, right, we can clustering with, for example, their topic like the sports, politics, technology, right? Those can be automatically grouped together. Okay. So the next one is the classification, right? Classification we have means we sometimes we have the predefined labels. So a common example is like what we discussed is the spamming email, right? So each email is classified as the spam or not spam, right? And if even though when they make mistake, we can manually correct them. So those are also um, text analytics categories class. And the next is the sentiment analysis. Okay, sentiment. This is actually extracts sentiment analysis to extract people's opinion from the text, such as usually it can be classified about the positive, negative, or neutral, right? So from a machine learning point of view, okay, sentimental analysis is usually considered as a classification problem, although sometimes it can be also treated as regression, right? So it's depending on how do you look at it, right? So of course, if you classify, for example, if we predefine the categories like the positive, negative, neutral, and each document will go to one of them, of course, this is by natural, this is a classification problem. However, if you consider about the opinion as a continuous value from, for example, negative one and the positive one, right? So if this is an example, right? So about the sentiment analysis of the Brexit. You guys know what is Brexit? Brexit? Sorry, the Brexit, right? Do you know what is Brexit? That means how British exit the Europe, right? So that was years before, right? You know, the British, the UK used to be a part of Europe, right? And years before they decided, okay, I'm not going to be part of Europe, so they had a vote, right? And Yeah, so this is the opinion about how people feel about it. Right? So usually the sentiment analysis can be classification or regression, right? So if we have categories like the positive, negative, neutral, then of course it's classification. So if we define their opinion from, for example, -1 to +1, right? The -1 means I'm negative, right? The +1 means I'm positive. And the 0 means I'm neutral. So this is becoming a continuous value. So in that case, that this problem can be considered as a regression problem. Okay, it's very natural, right? So here are some demo systems, demonstrational systems of sentiment analysis. If you are interested, you can click the link and I think most of them, they are toy examples, right? You can try out with different documents. For example, here we have 3 examples, right? So we talk about the sentiment analysis about for positive, negative, and neutral, right? So here are actually 2 online tools that can be sentiment analysis automatically. You can play with them, okay? So this shows a system that can take the raw text and produce a sentiment label, right? So they are already well-trained systems. Okay, so here are some characteristics of the text data, okay? So the question we think about it is that why text data is so difficult to analyze? Actually, this is essentially because here are the basic characteristics of the text data. Right? So the first one is that the difficulty is because the text contains many different things like the letters, the numbers, the punctuation, also the emoji, right? Nowadays. So for example, here, if you look at those examples, right, the words price and like 200, and also the symbols like the commas, example, the question mark. So they all appear together, and sometimes they have meanings, right? The second difficulty is that some of the words they appear too often, right? So, like there are stop words like the, right? In, to, right? So those words usually do not carry much meaning, right? But it shows up everywhere, right? A quick question. So, which is the most frequent word in English? You guess? Anyone make a guess? Which is the most frequent in English? I don't know. Is the the that is the most frequent one, right? Statistically, fun fact. Okay, so the third difficulty is that actually the same word can appear in different forms. For example, the hotel and hotels, right? Is the S, okay, and also the cheap and the cheapest, right? We have different variations of the same word with the same meaning, and I think that's an easy case comparing to Chinese, right? So the Chinese is more problematic. Sometimes even the same words have different meanings, right? Chinese is more complex for text mining, right? So because of these issues, we cannot directly use raw text. It's difficult to use raw text for analysis, okay? So what do we do then, right? So since we are gonna do the text analysis applications, but there are difficulties, right? So what do we do? Actually, we focus on what can text analytics can do is that we can do the feature extraction, okay? Like what we actually this is becoming the most essential part of today. That this is to answer the key question that how do we train raw data, like so textual data into numbers that a computer can help us to analyze. Okay, so this part actually includes 2 steps. The first one is what we call the tokenization, right? Where we split text into words and the tokens, right? Usually the tokens are the minimal element for text mining. So if you use ChatGPT with an API, your cost, how much money you're gonna pay, the payment is based on how many tokens you consumed. Okay. So the first step is what we call the tokenization. And the second one is what we call that there are actually methods, right? So to use the second step is the bag of words and the vector space model. Okay. Those are very widely used models and the techniques we're going to discuss later, which represent each document as a numerical vector. Okay. So eventually, every single document will be represented as a vector. Okay. So once we have those vectors, we can do things like the similarity search, for example, Google, right? Similarity search and also clustering later on. Okay. So from now on, we will focus on the feature extraction and see how do we perform it step by step, starting with the tokenization. The next slide. Okay. So we focus on identifying the most relevant. Think about this question, okay? Think about this question. So we think about how do we are trying to find the most relevant document with those query keywords. For example, you are looking for something with the hotel, right? The cheap, quite nice hotel, okay? Okay, so here are the documents. So let's examine each document closely, right? The document one says it's quite and cheap hotel, priced at $200. So it describes the hotel as a nice. So this document appears to fulfill all three keywords, three of the keywords, right? And document two states simply it's a quiet hotel and uses the term nice, okay? Well, it is just two of our keywords, but it didn't mention about the cost. It could be super expensive, which is crucial for our assessment. And the third one mentions the hotel is the cheapest among the hotels, but it also, here it says it knows that there's some noise. It's not so quiet. Okay, so the document meets the cheap criteria, but does not satisfy our quiet requirements. Semantically speaking, okay, Therefore, we evaluate those documents. Documents one, from a human perspective, seems document one stands out as the best match our query as it effectively encapsulates all the desired attributes. Okay, so this is actually a very toy example to illustrate how the process, how do we define everything. Okay. So why do we want to use that kind of example, right? Because in application, the application is very obvious, right? Basically, we can recommend something based on those keywords, right? In our case, it's quite cheap and a nice hotel searching from the tables, right? So we examine those the data, but we know the difficulty, right? Essentially, they are unstructured textual data, right? We do not have any relational database. We have no labels. And this is unstructured text data. So this type of data poses challenges for computers because it is not organized in a predefined manner, right? Like in always, right? So the first documents mentions like those issues, right? So we believe the first one is the best one. So this actually variation illustrates the complexity of unstructured data, right? So and the complexity of the unstructured data, right? Well, here is the idea. So let's think about now. We think about the extraction. So how do we examine the feature extraction on text data? So eventually, we are trying to transform the raw data into numerical features, right? So we can see that, we can from a high level, we are trying to convert the document here into a feature vector with numbers 1, 1, 4, 0, 1, that sort of things, right? Later on, I will also discuss explicitly how those numbers are calculated. But now, for the moment, you are trying to understand, okay, we are trying to convert those textual words the documents into an array or some numbers, right? And the second, with those feature vectors, we will continue our analysis. We will analyze those feature vectors, and then that will allow us to, to perform the following steps. Okay, and gain. Of course, the essential idea is to gain the insights from the data. Okay. So from the previous, we discussed how the document is most similar with query, right? That's basically a searching problem, right? So how do we do that? We need to convert the text data into a sequence of tokens, right? So this process is what we call the tokenization. Tokenization means we're splitting text into tokens. Usually the token are about the words. Okay, for example, the document is split into the words like the eat, hotel, quiet, cheap, nice, right? So we can convert those documents into different words, right? The set of words. So during the tokenization, we ignore the punctuation, okay, and sometimes we also ignore the numbers and the letter case, okay, because they usually do not add much meaning or semantic, right? For example, the hotel, right? We have the hotel with a capital letter H. It doesn't matter, right? It's the same thing. So actually, tokenization is eventually it is a design choice depending on the task. So for some of the tasks, maybe you can ignore all the question marks, for example, but for the others, maybe the question marks or the some symbols are quite important. The emojis also they are important from depending on your application. So how do we do tokenization is depending on your application. Okay. So after tokenization, we no longer work with raw text like the original input, right? We work with a list of tokens. So we explore basically a concept tokenization, which is actually a very fundamental step in the text processing. A simple approach. The most simple approach, I think, is to involve a few key steps like this one that we illustrate here. First, we split the text by space. So this is actually an advantage for English, right? Because in Chinese, we do not have space in a sentence, right? But in English, we have space between between the words. So that means each word or segment separated by a space is treated as an individual unit, or that's what we call the token in this case, okay? Then we ignore all the numbers, okay, and the punctuations, okay? So this simplification will help us to get the essential words. So we ignore those the symbols, for example, and the numbers. So we got a document with a list of words, okay? So in this case, we have, of course, we got duplicates because hotels appeared a couple of times, right? So by ignoring those numbers and punctuations, we narrow down the focus on. So now the documents becoming just words, right? So lastly, we also ignore the case, the capital letters. That means we make those data case insensitive strings as tokens, okay? So this means the capital letter, the hotel, right, and are ignored actually. So then now we have the tokens. So they are the tokens, right? Very simple, from documents to tokens. Okay. So after the tokenization, we find out that there are quite a lot of words that do not have much meaning, right? Those words are what we call the stop words. Stop words. Stop words are usually the phenomenon is that stop words they appear very often, like the a, the, into, right? Those and sometimes there are pronouns like the she, he, I, right? Those usually those terms do not reflect so much semantics in a sentence or in a document. Okay? You can see the example here. So after removing the stop words, the document keeps words like the words with more meanings, right? Or semantics like the hotel, the quiet, cheap, nice, right? Which are actually more descriptive to some extent, right? So so those are the most eventually hope that the idea is we leave uh, the informative words left in the document among the tokens. Okay. One important point here is that the stop words depending on the language. Okay, so English has its own stop words list. Okay, we already conclude that there's a list of stop words, and of course other language may have different ones. Okay, so by removing those stop words, we got a cleaner list of tokens. So like this one, right? And the next step is what we call the stemming, right? So, okay, what time is it? Okay, all right. So sometimes the same word can appear. The problem here is that the same word can appear in the different forms. For example, the hotel and the hotels, right? And the cheap and the cheapest, right? So basically, they express the same idea, but their representation they are variants, right? They look a little bit different from each other. So the streaming solve the problem. It converts everything from its base term. For example, it will convert the hotels to hotel, right? The cheapest to cheap. Right? But actually, there's a side effect about them. Sometimes when we do the streaming, sometimes we may lose the original meaning of the word. So there's a side effect from this problem from the streaming. But of course, in text mining, typically everyone does it. Right? So now all the words are in the same form, and we can, what we can do about them. All the words are in we can count, right? We can count how many times the same word appears in the documents. Okay, that's the problem. Actually, there's a very common process called the Porter streaming, right? Porter streaming. So this is actually a rule-based method. Basically, it removes the common prefixes or the suffixes in English without using a dictionary. Okay. And this method is actually proposed by a scientist called Martin Porter, okay, in 1980, right? Long time before. For example, the word computer and computational and the computation, they are actually they are reduced to the same uh, uh, term, to the compute, COMPUT, okay, to the same string. So this actually helps us to match the similar words more easily than across different documents, right? But of course, this is also sometimes problematic because after we do the Porter streaming, right? Sometimes the meaning or the original meaning may change. So this is actually a simple and a fast method, but not perfect. Okay? Still, this is popular and widely used in industrial applications. Okay? Here are some libraries for tokenization, so you can open it and download those. There are open libraries. They are all open source. Okay. For English text here, I think the NLTK is a classic library, right? And so basically, those libraries can handle tokenization, stop words, removing and streaming for us. Okay, and you do not need to code in your project. There's no need for your code for yourself. They are open, right? So after using those tools, you get a clean and normalized tokens, right? And those libraries are serve as very essential tools for handling text data in almost all applications, right? There are also libraries available for Chinese as well, right? Right. So for Chinese, we also need we need to because there's no space, right? In Chinese, there's no space among the characters. So what we need to do, we need to do word segmentation. Okay. So here are some popular Chinese NLP libraries available here. Okay, so these tools automatically split Chinese sentence into meaningful words, right? So for example, here, 今天, 天气, right? Of course, 今天 is a term, 天气 is another one. So those tools can separate those terms and make them into tokenization alike, right? Right? So after tokenization, we need to, we're trying to make analysis for text, right? So there's another important concept you need to get familiar with is the text corpus, the vocabulary, right? Those are important terms in text mining. Okay. Uh, so basically, text corpus is an essential term, okay, referring to a set of texts. Okay, a text corpus refers to a set of texts that we use for analysis or research tasks. Okay, it provides the material from which we can extract information and analyze the patterns, etc. So 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 on the slide, we can observe still there's with the running example, right? We can observe those documents that amplify this concept. So basically, document one describes the hotels with the quiet and cheap options, right? And with the $200, right? And document two retaliates this idea, simply, nothing that is about a quiet hotel, but express the positivity about the word nice, right? So nice is actually amplified. And similarly with the third one, right? So from those documents, we can analyze the vocabulary used, like and the sentiment and other patterns, right? So this analysis actually is to understand how people feel about the sentiment about the hotel, right? So you can see from the set of unique words in the text corpus is referred as the vocabulary. Okay, what's called a vocabulary. So we think about we remove all the duplicates, then we got a vocabulary list. Okay, so vocabulary is a set of all unique words that appear in the corpus after preprocessing, right? But why such definition of corpus and vocabularies, right? So we define vocabulary for important reason. We do not want to deal with unlimited number of words, right? It's like to define the scope of our analysis. So of course, later on, we're going to use them to build up our vectors, right? And we only focus on the words that appear in our corpus. Okay, for example, if we think about this material, then of course, for example, the terms that never appear in our corpus will be simply ignored. Okay, and of course, yeah, that's the reasons. Okay, and suppose we have the vocabulary of task. Now we have the vocabulary list here, right? We have the quite cheap hotel, noise, and nice. Okay, so each document presented reveals how these words are utilized in the context, right? So if we consider every single document, right? The extracted vocabulary includes, parts of usually it's a subset of the original task. Of course, they may initially they include duplicates, right? So every document can be rewritten with the vocabularies. Okay. So now we think about the third one, okay? Maybe because the document one is structured vocabulary includes the hotels, quite those are the terms, right? The two simplifies further representing with the quiet, hotel, and nice. And the third one, okay, the challenge here too is that how do we identify the appropriate vocabulary from text provided? The phrases indicate here, we have a tolerance somehow, right? The tolerance for noise, right? Because it says, although there are some noises, but it's cheap, right? It's the cheapest among the hotels. So there, it reflects some sort of the semantic reflects the tolerance, right? So document three should also include the noise, right, and the hotels and the cheap. But by using simply with the vocabularies, the analysis did not actually well represent the semantics itself, right? So here the analysis highlights importance extracting the precise vocabulary from text can enhance our understanding of the contents and the implications, right? All right, so here are actually okay, what time is maybe we take another break, okay, for 10 minutes. System, what is So we'll come back, guys. So I will continue to finish up about this part of the slides, and then we will continue with our TA to give a quick tutorial about so how to use the Python for the fundamental applications. Because actually the tutorial was already originally scheduled on the third week, but I think it's better to move it to the second, so you will have, longer time to get familiar with all the coding environments, etc., right? For get prepared for the projects and assignments of sort, right? So we were talking about the definition about the text, corpus, and vocabulary. Then finally, we have the opportunity to introduce the very old-fashioned model for text mining called the bag of words. Actually, this is the bag of words model comes back decades before, right? So, but it's a very classical method of analysis modeling, right? So basically, we see the bag of words model is a fundamental concept for the text processing, and this model treats a document as a collection or a bag of words, okay, without considering the order of of those words. So in the bag of words model, there's no ordering about in the vocabularies, okay. So in our example, we have three documents, right, from the previous here, right, from previous example. So we can see that the document one contains the word hotel, quite cheap and nice, right? So those with specific frequencies of each word. So notably here, the hotel appears 5 times. So the bag of words will indicate the vocabulary and how many times it appears in the documents. So we got hotel 5 times, quite once, cheap once, nice once, okay? Very straightforward. And document 2, similarly, we have quite, hotel, nice, which each of them appears only once, okay? And the document 3 has the noise, the noise, the hotel, and the cheap, right? Where the hotels appears twice. So you can see here we have a 2, hotel 2, right? While the other 2 vocabulary appears only once. So that's how we change the documents to the bag of words, right? So the table here, below summarize the term frequencies, the term frequency for each word or core 3 documents. For example, here in the document 1, quite appears once, the cheap appears once, and hotel appears 5 times. Okay, so we can see those are the numbers corresponding to those numbers. Okay, so this representation allows us to analyze and compare the content of different documents based on the frequency of specific words. Okay, this is what we call the very old-fashioned bag of words model. Okay, so actually, the bag of words model is eventually an example of the vector space model. You can consider bag of words as a very special case of the general vector space model. Okay, so after we did the tokenization, we removed the stop words, and then we applied the stemming, then we got the vocabularies, then we turn those tags into numbers. Okay, so this slide shows that how do we turn those bag of words model, right? So we can actually generate a vector space model. So we turn those documents into vectors. Okay, vectors. So the idea is quite simple, right? So each document is represented as a vector, and each position in the vector corresponding to one word in the vocabulary. So, okay, so this vector, those 5-dimensional vector representing the document 1, and each number indicating how many times appears in the document, right? So it's very straightforward. Okay, so each value in the value in each position indicates the number of times that the word appears in the document, right? So if we stake out the documents vectors together, we got a matrix. So overall, you can see this is a matrix, right? This is overall a matrix. So in this example, we have 3 documents and 5 words. So this, as a result, we got a 3 times 5 matrix. Okay, this matrix is numerical representation of the whole text corpus. So now we use a matrix to represent the entire text corpus. Okay. So now let's explain a little bit more on what these vectors really mean. Okay, the idea is called the vector space model, right? So in a vector space model, each word in the vocabulary becomes one dimension. Okay, each word is one dimension. So you can think of each word as one axis in a high dimensional space, right? So for example, our vocabulary includes 5 words, like quiet, cheap, hotel, noise, nice, right? Remember, those are the 5 words. So we have a 5 dimension, right? So each of these words defines a base vector. A base vector that means that's one dimension, right? It defines one dimension. For example, the word quiet is represented as this one, 1 0 0 0 0. So if we think about this quiet, think about a document with only one word quiet, then we have a document 1 0 0 0 0, right? So each of the term defines a what we call the base vector. Okay, and these base vectors are uh, orthogonal with each other, which means they are independent with each other, right? There are no dependencies. So a document is then represented as a t-dimensional vector. Here, t-dimensional vector, the t means how many vocabularies we have how many words we have in the vocabularies, right? So once we have the vocabulary, which is fixed, right, the dimension of all documents vectors is fixed. So, right, so that's how we do the modeling. That's what we call the vector space modeling, okay? So here's the question, right? So how do we get the T, or what is the T, right? So T is basically the size of vocabularies. So in other words, the T is the number of distinct terms in the documents. So think about T, for example, in general documents, T is our dictionary, right? If we hold a dictionary, then all the words we are supposed to know to describe the world or we can find from a dictionary, right? So, and that dictionary, that number of words define how many dimensions we have for the vector models, the vector space model, right? So, and the key idea here, this is actually quite intuitive, right? So each document is represented as a vector of numbers, right? And first we fix the vocabulary, and then we suppose the vocabulary has T words, and that means every document will be represented in the T-dimensional vector, right? Then we mathematically we have a expression here, right? So we write a document as a D sub j equals to the D sub j means the document, or the document equals W1G, W2G, and WTG, right? Here, WIJ means the weight of the words in I and the document G, right? So that's a very close word mathematical expression from the vector space modeling, but intuitively, that's basically a t-dimensional vector describing each single document, right? So because all the documents here we use same vocabulary, so the vectors are with the same length, right? So because of course we have the same the vocabulary, so the number of elements in each single of the vectors are of the same length, yes, right? Actually, that makes it, we can use this representation to make a comparison of different documents, right? So for example, we can measuring how close two vectors, right? How close our two vectors are. Of course, there are many ways. For example, we can compute the cosine similarity, etc. We have many ways to do that. Later on, so the document, the collection. So we can represent each document as a matrix, right? Remember, right? So it's basically a model of a collection of n documents, right? So we have shown that one document is represented one vector, right? And we move from one document to a collection of documents. When we have multiple documents, for example, in previous example, we got 3, right? 3 documents. So we pull all documents vector together, we get a matrix, right? So this is the matrix, and each row is a document, and each column is a word. Okay? Column is a so each entry in the matrix is written as WIG, right? WIG. So this value, what does this value mean? Right? This value means the weight of the words I, right? The word I in document G indicating a weight usually it reflects how many times this word appears in certain documents, right? That like what we discussed before, right? So if Wij equals 0, when there's a 0, that means the word does not appear in the document, obviously, right? So the document matrix is simply a structured way to store all the documents and all the word counts, okay, together. So once we have this matrix, we can apply many algorithms like similarity search, clustering, and classification with this matrix, okay? In other words, the documents matrix is a starting point for most text mining algorithms, okay? So any questions for this? Okay, let's look at because usually we have many words. It's a high dimensional, but sometimes we cannot think of we cannot think of the number of dimensions beyond 3, right? So let's think about a geometric interpretation in a 3-dimensional because we can easily understand the 3-dimension, right? So for example, here for the vector space modeling, suppose we only have 3 terms. The world includes only 3 terms, right? T1, T3, T2, okay? So this gives us a 3-dimensional space. So now we look at the document D, right? Say it's 2, 3, 5, right? Then this means the document, if in this very toy example, right? We have a 3-dimensional space and the document is represented as a vector indicated here, right? So this means the document has a weight 2 on T1, weight 3 on T2, right? And a weight 5 on T3. All right, so this is a geometric interpretation. But of course, when we have dimensional 4 or 5, it's difficult to visualize for our understanding, right? But conceptually, they are the same thing. So we can draw a document as a point eventually, or an arrow starting from the origin, right? So each in this in the 3-dimensional space, each point in the space indicating one document. All right. So this is actually a very powerful modeling, right? Because we can compare the documents. Comparing documents becoming easier, right? Because we can simply measure the distance or the angle between those points, right? So if we consider them as the arrows, right, the vectors, then we can compute their angle, right? If we think about as points, we compute their distance, right? So, for example, here for still on this, think about when we have a query Q. So which one is more like Q? We can compute, right? D or D prime. Which one is more? We can draw both documents as arrows starting from the origin, right? And then we have a query Q here, right? And to answer the question, we need a way to measure the similarity between the vectors. Of course, there are many ways to do that, like the distance, angle, projection. Eventually, I think the most widely used is the cosine similarity, right? So intuitively, all the documents in the space, they are at the points in similar directions, right? So the documents are similar directions. They are more similar with each other, right? Even though the length may be different depending on how many words. That's a different thing, right? So the similarity between the documents become a geometry problem, right? So that's the different ways, okay? So I think I will stop here today. So of course, we already discussed all the modeling. So the next thing is very obvious, right? We are going to discuss how do we compute the similarity among different vectors. right? So many of them are basically high school math, right? It's easy. But I'm gonna stop here for today, and I will give the floor to our TA for the tutorial, which will discuss about the Python installations, and we will also play with a toy example, so that will be helpful for your coming projects and assignments. Okay. Yeah. Any questions so far? Okay. If no, maybe you okay. Yeah.
Hello everyone, I'm the TA for this class, and today we are going to have our tutorial one. I have already uploaded three files in the Blackboard. You can check the information here. The first one is the code we are going to use today, and the second one is the main content about this tutorial. And the third one is that I have already recorded a video for this tutorial and just for your information. And let's start to check this video. And for these tutorials, there are mainly three content. If you have not installed Python and Jupyter, and the first two steps is just taught you how to install these two apps. And then we are going to use the Python to do a very simple task. That's to do the data clustering. And let's start with the video, and I will give you time to do the practice. Sorry. Recording. Okay. Duplicate. Oh, okay. Okay. Class, and today we are going to have the tutorial one, the installation of Python and Jupyter. In this tutorial, we will discover a popular programming language, Python, and one of its editors, Jupyter. Moreover, we will also try to discover clustering by using Python. These tutorials, some of you may use Windows, and some of you may use the Mac OS. Both of them are okay. First, we will introduce the installation of Python, and then about its editor Jupyter and some other PostGO applications. And finally, we will give you an example on the use of this program for the data clustering. First, let's introduce the Python. Python is a popular programming language which is easy to use and learn. Python has various kinds of libraries which can undertake different types of tasks. For example, if you want to do data analysis, you can use this kind of libraries. And for machine learning, there are two popular ones, the TensorFlow and the PyTorch. And if you want to do some website development, you can also use some associate libraries. That's about the advantage of Python. There's already some libraries you don't have to develop them yourself. You can use them directly. And first, Python is highly popular among programming languages. It ranks #1 on the TIOBE index in January 2024, which measures the popularity of the programming languages. First, for the first part, this video just introduce how to install the Python. If you have already installed the Python, you can just skip this part, and I have already uploaded the code, and you can first try to use to run the code on your computer. And for those who have not installed the Python, you have time to install the Python first, because in the next tutorials and class, you may also need to use the Python for this. I will give you some times if you have not installed Python yet, and now you can use the website to visit the Python and download the Python according to the version of your operating systems. And now you may have time to do this. If you have not downloaded it, you can visit the link. I have already uploaded the tutorial materials on the Blackboard, and you can use these two materials. And you can find the one that's suitable for your computer, and then open the setup and install the Python as instructed. And after you have installed your Python, you can use the cmd command prompt and to tap Python and press enter on your keyboard. Your installation will be successful if your Python program is running. You can tap quit and press enter to exit Python program. And next, we are going to introduce Python's interpreter. Unlike the C and C+ programs, the Python must be executed by a Python interpreter. And Python can also be installed in other ways, such as the Anaconda. You can visit Anaconda website for details. For example, like this, you can download Braille and use the Anaconda. And after you have installed the Python use a package management system pip to manage the Python libraries in your computer. That means if you want to install some libraries, you can use this prompt directly. First, you just press Winter+R on the keyboard and tap cmd. And in this, right, in this terminal, you can install a library that tap pip install and plus your library's name and press enter, and then you can install the libraries you want. And if you want to install a library, you can use the pip and install plus your library's name. And how to learn Python? There are some basic concepts. First, we need to learn the concept of a variable. That's a place to store data. And then there's a function. That's you means you the basic unit to do something. You give some inputs, and after the function, you will return some outputs, just like this. You have a number. You want to find the square of the number, and you use this function to calculate the square of the number 3. And the third one is the hierarchical functions. That's a library include different functions. Python use a dot to indicate affiliations. For example, we want to call a function add in a library called math. Then we can use the function like this, math.add, to locate it. And if you want to know more information, you can find the contents in these two links. And now, since we already have a Python, we can use different text editors or IDE to write Python code, such as the Visual Code and PyCharm. And to run a file, including Python code, you can open a command prompt and tap Python file to write Python interpreters to execute the codes. And now, let's introduce the Jupyter, or visualize the patient notebook. Jupyter is a web platform. This can be used to write code snips and add documents and test program, all within a web page. First, you can install Jupyter. Just you can install by the prompt and use the pip, and just use the pip install Jupyter. And then to install the libraries, we can use the following parts. Tap the app install Matplotlib, sklearn, numpy, and so on, and enter press. After this, you can have this libraries. Next, we are going to use the libraries to do the clustering. And if you already have the Jupyter, you open the tutorial folder. I have already upload on the Blackboard, this one, and you can use the Jupyter to open it. And this is the Jupyter interface, and you select the right kernel and open it. Okay, now I will give you maybe a few minutes if you have not installed the Python, because next we are going to share a case about the data clustering, and you may need to do the practice. So if you have any problem, please raise your hands. I will answer your questions. Thanks. Any questions about installing the Python and Jupyter? Okay, then I think all of you have no problems about installing this very simple one. So then let's just skip this part and to do today's tutorials about the practice. So now you will have time to open the file I have uploaded on the Blackboard. Of course, apart from Jupyter, you can also use some other interpreters to open the files. So now you will have time to do this. And since all of you have opened the file I have uploaded, now let's do a small example for the data clustering. Here we have the code. And the first one, we of course that's the print function and print the hello world. And next, we want to use a function called time. So we import the library time, and we want to know the current time. So we set it and know the current time, and then we use it to print the variables of all. And next, we are going to do a cluster in demo. Here, we will use the clustering method provided by a library sklearn in Python to generate clusters for given data points and compare the difference between k-means and the dbSCHEME. That means we have the data and we use two different methods to do the clustering. And after this demo, you will understand the difference between the two methods and what kind of data they are suitable for to do the clustering. Now, first, we need to import some necessary libraries. That's the library list as this. And we need to execute each one. And then we need to define the number of data points. Here we choose 300. And then we want to use the function make rows. Here we introduce it here. That means it can generate n sample data points with randomly seed with the random state. And the data will be in a brown seed. Here we generate the data and plot the data like this. So here you can see that there are the 300 data points generated by this function. And next, we are going to use the generate points in moles. That means another function that will generate sample data with random seed. The point will be in a mole seed, and just like this. And after this, we want to do the clustering on the data. First, we choose the k-means. We can first introduce the sklearn clustering libraries, which one is k-means. And then for the k-means, we need to first set the number of clusters we want to obtain. So here we set the number is 3, and then we use the k-means to cluster the data we have generated. And after this, we will plot the different cluster of points and the central of the cluster. So here you can see that based on k-means and the Brown generate data points, their performance is quite good, and they divided the data points into 3 obvious different clusterings. And after this, we want to cluster the data for the moons. And here, since we want to set the cluster is 2, and after the function, we find that this seems not very good. That's based on the nature of the k-means. So for this function, for this situation, we may use another clustering method, the dbSCHEME. The dbSCHEME can process data in a non-complete state very well. And here we introduce this method, and then we do the clustering with this method. And after this, you can see that the performance is quite good. So here you can see the difference between different classing methods. So now it's your turn to do the testing, and if you have any questions, feel free to ask. Okay, now if you have a computer, you can start to run this code. And if you encounter any problem, just raise your hand.
So guys, do you follow the installation? I believe it's if you got engineer backgrounds in computing, I believe this will be relatively easy. But I understand some of you guys got quite different backgrounds, right? So when I was teaching similar material to management, I got another class in the management school. So they had a lot of problems to installation, but for if you are a coder, I believe this is naive, right? So you guys have questions? If no, I think we can call it the end of today. We still have roughly 10 minutes on the clock, and I'll be staying here to answer any questions related to either the tutorial or the class, or anything about you want to ask. Okay. Yeah. Thank you very much for coming, and I will see you next week. Next week is not holiday, right? No. Okay. I'll see you next week. Right. Of course, you are free to take chocolates. Okay. Yeah. Okay.